Question says, a motor car is moving at 72 kilometers per hour. The driver sees a pedestrian step into the road and start crossing. At the moment that the driver applies the brakes, the pedestrian is exactly 80 meters ahead of the car. The brakes cause an immediate retardation at a rate of 2 meters per second squared. Will the car stop in time to avoid colliding with the pedestrian? Show all calculations in arriving at your answer. So we have four equations of motion as given on page 16 of your textbook, and to solve such a question, before we even look at the equation, before we look at the equation to use, we first need to understand exactly what the question is asking us. So let's read the question again. So the question is, will the car stop in time to avoid colliding with the pedestrian? So exactly what is the question asking? It can be useful to draw the diagram of the situation so that you can understand exactly what the question is asking. So yeah, now as you can see, I'm drawing the diagram. This gives me a better view to the question. So now we have the car here and we have the pedestrian there, and they say there is 80 meters ahead of the car, and the question is, will the car stop in time to avoid colliding with the pedestrian? So as you can see, the question is saying, will the car stop before 80 meters or after 80 meters? Because if it stops before 80 meters, it means it will not hit the pedestrian. But if the car stops after 80 meters, it means because the pedestrian is in the way of the car, it means the car will hit the pedestrian and then stop later. So in other words, this question is asking for us to calculate the displacement. So what is the displacement that the car is going to have before it comes to a complete stop? Okay. So now we've established what we need to calculate in this question. Now we need to establish what parameters we have in the question. So now let's look again at what the question has. So here we have 72 kilometers per hour. So what is this? So 72 kilometers per hour, this is the initial velocity, because remember the final velocity will have to be 0, because the car, we want to know what happens when the car comes to a stop. So the final velocity will be 0 meters per second. So in this case, the initial velocity is what? 72 kilometers per hour, which the textbook has converted for you guys here as 20 meters per second. So we know that we have u is equals to 20 meters per second, v is equals to 0. What else do we have? Oh, we have a retardation rate. So what is retardation? Retardation is the opposite of acceleration, which means that the retardation rate is the negative acceleration. So in the linear equations of motion, we have acceleration in the equation. So it means for the value of a, we will write it's equal to negative 2 meters per second squared. All right, so that's that. So now we have three parameters. We have u is equals to 20 meters per second, v is equals to 0, and we have a is equals to negative 2 meters per second squared. And we also have established that we are looking for displacement s of the car. So now we go and look at the equations, and then look for the equation that has these parameters. The first one, v is equals to u plus 80, does not have displacement in it. The second equation, v squared equals to u squared plus 2as, has all four parameters that we have. Well, three parameters that we have, and the one that we are looking for, the displacement s. So it means that is the equation that we need to use. That we can forget about the rest of the equations. They have time, and we are not working with time. We are not looking, or nor do we have time in the question. So now we substitute the values. V is equals to 0, so 0 is equals to 20 squared minus, so because a is negative, so it means it changes the positive sign there, so it becomes minus 2 times 2 times s. Now rearranging the equation, we have s is equals to 0 minus 20 squared over 2 times negative 2, and then that gives us a displacement of 100 meters. Now because the 100 meters is greater than 80 meters, it means the car will not avoid hitting the pedestrian. In other words, the car will hit the pedestrian. It's quite a sad sum, but anyway, so it means the car will not be able to stop in time to hit the pedestrian. I hope this has given you some insight on how to tackle questions of horizontal motion. Now you can look at example 2 and also do the questions on page 20. No, not page. Yeah, on page 20. Yes, on assessment activity 3.2. And if you have any questions, please be sure to send me a message. All right. Thank you very much.